Hello everyone. In this chapter, we'll learn how to create pipe fittings using lookup tables with the size lookup function. Lookup tables contain type data, allowing you to define multiple part sizes without having to create separate family types for each one. I'll walk you through the process step by step, first creating an elbow, and then using it in an actual project with the appropriate pipes. Let's get started. First, I've opened a reference Excel file that includes all the pipe sizes and their necessary values for building an elbow. Data from lookup tables is stored within the family and accessed through the size lookup function. For this exercise, you'll need two files, one for a 90-degree elbow and another for a 45-degree elbow. Go to File and save both as CSV files, since Revit reads lookup data in that format. It's important to keep the original Excel file as a backup. If there's any issue with the CSV file, you can always go back and export a new version. Next, create a new family using the metric generic model template and name it Exercise UPVC Elbow Revit 23. Then, go to Family Types, choose Manage Lookup Tables, and import both CSV files, Elbow 45 and Elbow 90, into Revit. After importing, create two new text parameters and name them after the corresponding lookup tables. In the formula column, type the exact lookup table names enclosed in quotation marks to ensure they're correctly linked. Now it's time to create parameters for each required value and set them as instance parameters. Since the elbow has two variations, 45 degrees and 90 degrees, we'll use the size lookup function combined with an if function in the formula column. This formula will define two cases, one when the angle equals 45 degrees and another when it equals 90 degrees. This setup allows Revit to automatically retrieve the correct size values from the corresponding lookup table based on the chosen angle. After creating and importing formulas for all the parameters, enter the angle and nominal diameter values. If all the other parameter values appear correctly, click Apply to confirm. When the center to radius distance is too short, we can't create the elbow in the usual way, which typically involves modeling the middle section and the two ends separately. In this case, we'll use a slightly different method to build the elbow. Start by going to the reference level view. Create a new reference line extending from the center point. Then measure the angle and assign it to the angle parameter. Mirror this reference line vertically, then offset the new line inward and set the center to end parameter. Measure the angles again to ensure they're exactly 90 degrees and lock them in place. Next, create a new reference plane on the left side of the center left-right plane and set its distance using the center-to-end parameter. Now, create a new reference line using the center-end arc option. Align and lock the arc with the reference planes. After that, create a sweep form. Start by sketching the path, aligning it with the reference planes, and setting its length according to the h parameter. Open the Family Types panel and adjust both the angle and nominal diameter a few times to make sure everything updates properly. Switch to the 3D view, select the profile, and choose Edit Profile. Draw circles that correspond to the nominal diameter and the outer diameter. Then click Finish to complete the profile. At this point, the basic shape of the elbow has been formed. To refine it, we'll create the curved corner. Use a void sweep to cut away the sharp, pointy section of the elbow. Finally, create another sweep to fill in that corner, completing the smooth, curved shape of the elbow.
Looking for piping catalogs you can trust? At pipingcontent.com, you'll find ready-to-use libraries for AutoCAD Plant 3D, Revit, Smart 3D, E3D, and more. Get instant access to valves, fittings, and components. Click on the link below in description section and explore pipingcontent.com today.